In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Greetings, the Astro 30 here, yet again with another box of PCBs. Now I can't remember, or I'm not sure which one's which because I got two boxes today. So I'll just open up this box. It's the heaviest, so I assume it's the one I want right now. So cut the tape somewhere. How's that taped? Box is a bit, damaged here and there. There we go. But that's fine. Ah yes, here we go. So this is my amplifier power supply module and DC protection. So the day's finally arrived where I assemble and test this. So I need to get the bubble wrap open. That's pretty sexy looking actually. That turned out quite well. I'll have to check my fitment of my relay in a second. And the PCB mount heatsink that goes over here, which I can actually just do now because I have the parts sitting off to the side here. Here's the heatsink. Righto, doesn't fit. That's annoying. Yes, I got the micrometer to work. It's more like 2.2. God damn it. So that's not going to fit in those holes, which is thoroughly frustrating. I mean, they are just blind holes. They don't actually connect to anything. I could just drill them out, but yeah, I thought that my measurement was correct. It appears not to be. Okay, well I can always pull the pins out. There's enough room on there for it anyway, so okay, all good. Not a great issue. It would have been nice to have it board mounted. That means my other PCB is going to have a similar problem, and we'll find out that in another video. And the bridge rectifier doesn't even fit in the holes. Are you serious? Man, this is double-sided board too, so that's going to be awkward to fix. It's 1.2 mil, and the holes should be 1.2 according to the Gerber. So I don't know why this won't fit in there. And they don't. What a pain in the ass. Alright, I'm going to try the relay now. Nothing fits. Are you serious? Right, in order to make this fit, I'm going to have to probably just take a Dremel to the pins here and just shave off a little bit of material on either side, just to make it fit in the hole. Probably the same with the bridge rectifier, because I don't want to go drilling the PCB because, yeah, that's never good. This is frustrating as hell now. I'm not exactly 100% happy, so, but it is what it is. Yeah, as for this heatsink, I might be able to shave a bit off to make it fit, but it looks like quite a bit's got to be shaved off, so I might as well just, remove the pins. Negates the fact that it's got solder pins in there, but oh, I'm annoyed. Now I thought I checked these measurements like 100 times, but apparently I did not. I mean, I can jam it in there and it sort of fits, but that just means I need to just shave off just a slight little bit. Bridge rectifier. Yeah, those holes look way too small. I mean, I could drill them out because all the actual track connections are on the underside, so it doesn't really need the top side. And if I put this up proud of the board a bit, I can actually then just solder from the top. I mean, it's something I don't want to do. And I also don't know if I've got a drill bit that's the right size. So there'll be a link in the description to a PCB for this if you want to order it. But you may have to end up drilling these holes out because I don't really want to shave these down because it'll just probably expose bare copper there, and it sort of takes the current capability out of the wire. That drill bit looks like it's going to fit. So, yep, I'm going to lose plated through holes, but that is what it is. Hey, shit! Excuse me. Alright. I've been sneezing all day and yesterday too, and I don't know why. Okay. I can't do this with the relay because I won't be able to solder from the top. Not that any of the pins solder to the top, I don't think. No. Oh, the ground does. Okay, so I can't do that. So I have to clear out these holes of the drilling swath. Now, it's a bit rough and ready, but that should fit now. I hope. Yes, it does. There we go. Problem solved there. Spacing's a little wrong too, but okay. I can solder that in now actually, so I'll just move my drilling apparatus out of the way and then I'll work on making the relay fit. So I'll just solder one pin to get him straight. Okay. Now obviously the solder is not going to travel up to the other side. That's okay. Now I can solder the other pins. Finally, lucky last, this one. Okay, that's soldered in, so now I need to trim off the excess length. Like so. And part of me is thinking, do I even need to bother to solder the other side? And part of me is saying, yeah. So, I went to pick up the drill as a soldering iron, that's not going to work. So because I've left myself enough space, I can just do this and solder it from the top side. And this is what we used to do when you made your own double-sided PCBs at home. It's almost next to impossible to plate the through holes. So you'd had to solder from both sides in order to make the connection. So now that that's soldered in properly, I can then move on with the assembly of the rest of it. But first, I have to make this relay fit. So I will just get a Dremel and I'll trim off some of the excess. Change of plans, I'm not even going to do that, I'm just going to use a file. Because I don't think I'm going to have to take off much material to make this fit. Yeah, hardly any. Okay, so that's alright. So let me just work on this off camera and we'll check our fitment. Yeah, that's not too bad now. It's a bit of a tight fit. So I might just work these pins a little bit more and see if I can get it to just like slip in not so tight. That's what she said. Yeah, that's a lot more acceptable now. The relay's gone in almost flat to the board. I mean, it won't go completely flat because of how these pins are wider at the base than they are that go through the board. But there's enough material sticking through to solder it, and I can still get the relay out. So let's fix that problem. Alright, so yeah, I'm just going to negate these pins. Just pull them out, if I so can. Okay, I'm not really going to bother trying to do that now. I'll just use a different type of heatsink that I've already got lying around. This day has been a complete annoyance from start to finish, so I'm not happy about anything at the moment. And yeah, at least the transistor fits in the hole. So we had problem fitment with the relay, problem fitment with the bridge rectifier, which has been fixed, and make sure that that's put in the right way around. So yeah, that was kind of annoying. So however, everything else should fit. I've got all the other components to construct it. Now, I was going to mention that there's one thing I'm not going to do, is I'm not going to put the 2K7 in here, which goes to the power LED. I'm not going to put the 2K7 in here, which goes to the protector LED. I'm not going to put this 1K resistor in either, and there's a reason for that, because one side goes to the positive, the other side goes to the collector of this NPN transistor, which basically brings whatever is connected to here, which is the 2K7 resistor in this case, to ground, so it turns the LED off. I'm going to put wires in these two positions of the 1K resistor to go to a multi-vibrator board which flashes an LED on and off, and then when the transistor brings this side to ground, the LED will become on permanently. So that'll be the switch output, that'll be the positive rail, and ground I can just take off of the cathode of the protector relay. So there we go. You don't have to do that, but that's how I'm going to build mine. And I'm not going to put a connector in here for the thermal switch because I haven't decided whether I'm using one or not yet. So next thing to do would be to get the thing built. I'm going to start with all the low profile components such as the resistors, the diodes, and then I'll put the power resistors in, and then the capacitors, and then finally the large electrolytics as well as the connectors. So let's get going. Right, and just as a quick side note, I've got the pins out. I'm going to mount this BD139 transistor with a little bit of heatsink compound. Interesting, it's got no nozzle. It was the same type I had before, whatever. Okay. So much water in that. God, blimey. I just need to get all this crap off that isn't needed. Try and get it straight as possible. Okay. Get off this excess crap. Alright. So that part's done. I didn't need to do it now, but I decided to anyway. And that should fit nicely in the board. Maybe. Maybe not. Yep, there we go. And there's plenty of lead length there to solder to, so yeah, that'll come out nicely to the board. And I'll just mount it up flush. There's no tracks there. No, there's no traces. So that's fine. Alright, that's all the low profile half watt resistors put in. I'm going to move on to the diodes now, but I do really need to start getting ready to go to work. So I might have to pick this up a little later, but I will insert some diodes. Just get things started here. Of course it doesn't want to come all the way through. Right, that's one of those rectifier diodes. Now I need to do the second one, which is the other two, which are for the 4-wave rectifier over here. Right, that's one of them. It's because the leads on these diodes are bent all over the place because it's been in and out of breadboard. That's why it's hard to get in, because everything is just like twisted. But once I get it started, I can pull the rest through with a pair of pliers if I can grab hold of it. Like be a little bit forceful, but not too forceful. Don't want to damage the component, just need to get the thing started. Oh, I might just do it like Chinese electronics do, just put it at an angle. No, I'm not going to make it that bad. I like to get things flat. So I'll just solder these in and then I'll start getting ready for work. And I'll pick this up later after I've finished probably. Or I might leave it till tomorrow. I don't know what I'm going to do yet, except solder these diodes in. Because I've already soldered the bridge rectifier in, it makes it kind of awkward to solder these things in because I'm chasing it around the desk, but it's fine. Alright, so that's those three, one in, 4004 soldered in. I might have to get myself another pair of cutters because the blade it's got kinks, like dents in it, and it's not cutting properly. So I tried to cut something too thick. Right, so that's the, ooh, that one came up at how you doing. Okay, let's see if I can fix that. That's a bit better. Okay. Alright, let's fix that one. Now I can probably put my 12 volt Zener in and my 24 volt. Right, I've got some progress. I've got the connectors in, the spade terminals now. I don't have quite enough. I need 9, I only had 8 and I ran out. So I'll have to get another packet of 8 just to get one more. Zener diodes are in, and I came up with a solution for the heatsink over here. I used a couple of PCB pins because they sort of just sit in the hole. They don't fall right the way through. Well, they do. But if you prop it up on something when soldering, you can get it to kind of behave. And what this will do is allow me to put the heatsink on the PCB, and it will stop it from bending around so you don't accidentally bend the transistor or whatever. So that's okay, I guess. That solves that problem. So now I need to move on to the larger 1 watt resistors, the transistors and the capacitors. So that's the next step. Alright, with all the transistors, resistors and capacitors, the low profile ones, soldered in, I'm going to install this BD139. If I can get it to go in the headers. There we go. Okay. I want to make sure that that is as flush as I can get it. bloody moved. Still not all the way down. Yep, now it is. Okay. Okie dokie. Let's retouch that one up. Just give him a trim. Alright, so now I can move on to the next tallest component. In this case it's going to be the large filter electrodes. These 63 volt 4700 microfarad. Good one. Two. Three. Lucky last, number 4. It's starting to look like something now. I can turn him over. Alright, that's them in. It's really starting to take shape now. So I might as well install the last component, which is the relay. Making sure that it's flat all the way along, which it looks like it is. And there we go. That is completed. I'm quite happy about that. I might have a good about that later. I actually might take this to cash converters tomorrow and see if they'll give me some money for it. I doubt they will. That was, I'm sorry, but that was funny. Yeah. I'll take it to cash converters, hock it in. I'm not really worried about this spade terminal. I can just insert it into the holes and solder it in later. But yeah, so now we're ready to test this thing and see if it actually works. So what do we do when we test an unknown power supply? That's right, we put it on a dim bulb. So that'll be the next step. However, it's late at night now, so I might actually do that tomorrow. I'll just edit what I've got done now down. And, I mean, it's not like, you know, rigid or anything, but those PCB pins did actually, like, help to a point. So, alright, I'm going to stop playing with that. So, yeah, I might put some standoffs on it first and then we'll go about testing it. So that'll be tomorrow's little escapade. Alright, see you then. By the way, thanks Jeff for those capacitors. I've used 5 of them now. I've still got 1 left, which I have no idea what I'm going to do with it, but yeah, that's cool. There's quite a bit of weight in this board now. Anyway, see you tomorrow. Well, it's the next day, and I'm ready to test this power supply. Now, you may be wondering why there's clip leads connected to the transformer connector. Well, I've got that going off to a DC supply set around about 18 volts, and I'm going to test the low side circuitry here, the protection circuitry. Even though it uses a 4-wave rectifier via these 2 diodes on the center tap of the transformer, and it will not work if you only connect one end of the transformer to one diode. It doesn't matter for DC. To DC, those diodes aren't a half-wave rectifier. They don't even exist to it. So I'll turn the power supply on. And there we go, the relay engaged. Nice. So we'll test by taking the positive lead and putting it to the left end, for instance. Drops out. Resets. Right in. Sweet. So that circuit is operating. I can't test negative going DC because, well, it's only a single-ended supply. But I'll test that on the transformer. Now, what I want to do is I want to test whether we've got continuity across the input and the output connectors here. Yes. No connection. Yep. And when it's off, there should be no continuity, which there is not. Okay, so this is ready to hook up to a dim bulb and transformer, and well, we'll see if it all plays nice or goes up in smoke. Alright, got that set up. Just my 160 VA 25025 transformer, dim bulb, and I've got a clip lead connected to the ground over here going to the negative of my multimeter probe so I can take some voltage measurements. And we'll just turn it on. Bugger all inrush. And there goes the relay. Beauty. So I'll just touch that. That will start dissipating heat because it's dealing with ripple as well. So let me just take a high side voltage measurement. 38 volt there on the positive, and negative 38 volt on the negative. Great. So as to what we've got at the emitter of the regulator, 11.2 volt. Yeah, that's good enough. Sweet. That's not going too hot at all. Okay, so let's reconfigure this. Beauty. And we'll test the negative. Perfect. You could literally leave that connected all day and it shouldn't really affect anything. Doesn't seem to be. Well, that power supply and protector unit is working perfectly. I'm very happy about that. So I might leave this video here. If you want to purchase this PCB, be aware of the slight modifications you have to make. I'll put a link in the description below to where you can order that. And in the meantime, I'm going to say thanks for watching, and I'll see you in the next video. Have a great day.
Thanks for watching. Please remember to like, comment, subscribe, and share the video. I'm Samuel Jones. This has been Astro's Electronics Lab.